Algebra 2, this should look familiar. Like, oh yeah, I have seen that long formula before. I don't necessarily memorize, well, I mean, I guess I do kind of have the numbers or the letters and things memorized, but like more importantly, I try to think about it like, okay, like what things am I trying to find, and then which letters did I actually use on the other side? So this would be like if you were trying to solve for side B, because you'll have B squared all by itself. At the end, you can just square root everything and you'll have B. Notice that it starts by adding the two other sides, so I would know sides A and C. So I add the two other sides, the sum of the two other sides, or the square of the two other sides. And then I have this minus 2AC, so that's the same 2 that I know, right? And then it will always be times the cosine of the angle, and this angle will always match the side that you're trying to find. So you don't necessarily have to write down all the versions, but just FYI, there is a version for A squared, right? And it's going to be sort of in the same setup, that you would start with the other two that you do know, so the B squared plus C squared. They almost always, like when you say it out loud, it starts to feel like the Pythagorean theorem right there, okay? But of course, it's not just a right triangle, it's used for non-right triangles. So there's this other piece that, you solve for in the blue packet. So this would be minus 2 BC times the cosine of whatever angle you're going to put there is going to be the angle opposite the side we're trying to find. So A. And then, of course, you could write one for C, right? C squared equals A squared plus B squared minus 2AB times cosine C. I'm certainly not advocating for memorizing, because like this would potentially be, because I'm going to give you a version for angles, this could potentially be 6 different formulas, and I would not say you should memorize each individual one. It's know one and be able to change the letters out, okay, for a given problem. This one I'm going to title, this is finding a side. So B squared, A squared, or maybe a C squared. If you want to write that one in your notes, you certainly can. You can probably find it in the textbook or certainly Google it. And this would be the case, you have to know two sides, and you have to know an angle, but it's not going to spell a bad word like yesterday, two sides and an angle. Okay, side, angle. That would be the ambiguous case. That would be law of sines. Okay. This one is going to be the two sides and the included angle. So if I know two sides and the included angle, like on the board over here, I have this picture, okay, just to review area, but I don't know the side opposite the angle that I would know, and so I wouldn't be able to set up a law of sines. I don't have enough information for law of sines, so I would use the law of cosines. I can amend this or sort of manipulate this formula that you solved for in the blue packet, and we can also use the law of cosines to find an angle in the case of side. What if you know all 3 sides of the triangle, but you don't know a single angle? If you don't know a single angle, you can't set up any law of sines, because it requires that you know an angle and the side opposite it. So for this formula, essentially what you're doing is, like we would take this formula that I have here, B squared equals, and I would try to get the cosine of B all by itself. So subtract the A squared, subtract the C squared, divide by negative 2AC, and this formula will look like the cosine of B equals, and you do some, if you really work that out algebraically, you'll divide by a negative, so you'll change all the signs. It'll be A squared plus C squared minus B squared all over 2AC. And again, I try to think about it in terms of like patterns of what I'm trying to find and the things that I do know. So this is like when I'm trying to find angle B, then I start by adding the square of the two sides not opposite angle B. I'm always subtracting the square of the side that I'm trying to find the angle for. So if I was doing a cosine of A equals, I would know that up in my numerator, opposite of angle A is side A, so that's going to be the minus A squared. And then the other two will be like a B squared plus C squared, and you always divide by 2 times the first two that you use, the positives. And of course there's one for C as well, right? Okay, so last thing, and you'll see this in our example, pay attention, and if you need to mark something in your notes, please do that. You're not finished when you just do the right side. This is equal to B squared, so you still have to square root both sides. So that number will get smaller. And then on this one, beware, this stuff is not just going to be your angle. It's actually going to be a very small number. It's going to be the cosine of the angle, which, like sine, has to be between -1 and 1. So it's going to be a decimal. And what will you use to solve for A then, angle A? What will undo the cosine? Inverse cosine. So you'll be doing second cosine in the calculator of that ratio. It is very easy in each version of these formulas, since you've been practicing the law of sine so much, to accidentally write sine right there. And that's one of the times where, like, showing your work, I know you're like, I can just calculate it on my quiz or on my test. I don't need to write stuff down. But if you put sine 50 in there and it's supposed to be cosine 50 and you don't write it down, I'll never know what you typed into the calculator. It's a mystery to me, so then I have to take off more points. Versus when I see that sign, I can circle the sign and I could take off like half a point because you're just, using sign. So beware. Okay, and then the last thing that I'm going to mention before we do an example is be really careful on this one because you have a fraction. You got a numerator and a denominator. And in the numerator and the denominator, you have like operations, right? Addition, subtraction, multiplication. So a lot of our calculators are going to require us to be very specific to the calculator. Add and subtract all the things in the numerator. So put it in parentheses. Multiply all the things in the denominator, 2 times B times C. And then divide the two numbers. Okay, so you have to protect it with parentheses on the top and the bottom. Some of you might have a calculator that allows you to make it look like a fraction, and then you don't have to worry about this. But if you're going to hit divide so that it looks like division, you're going to need the parentheses. Otherwise, you'll get like errors, like you can't inverse cosine. Okay. We're going to do an example. Okay, so suppose we know angle B is 81 degrees, side A is 22, and side C is 19. Imagine this is your quiz on Thursday. All the triangle problems are just going to be mixed together. Law of sines, law of cosines, ambiguous case, side, 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 whatever they may be. And some people have the big question of like, how do I know when to use which formula? Well, just looking at these three things, I know I can't start with law of sines. I know angle B, but I don't know side B. And there's no other way for me to find another angle. So I'm kind of stuck with law of sines, law of cosines. If I draw the picture, you might be able to tell 81, 22, and 19 that this is a side angle side. So if you know those kind of things, side angle side is always going to be law of cosine. So that means for side angle side, we got to solve for what first? B squared. Sure. The missing side. B squared equals A squared plus C squared minus 2 times A times C times, make sure you write the cosine. It's the law of cosines. times the cosine of 81. Type it into your calculator. I recommend really just like type it all in from left to right. I really don't recommend doing it piecewise because then you have to pay very careful attention to your order of operations. So if I type all that stuff in, I'm going to get 714.22 and some other numbers. That might feel a little off for that triangle to have that side be 714. So if you're looking at it like that's a really big side compared to my other sides, remember you're not done. You have to square root. Excellent. Remember that function also you can use it on your calculator. Like second x squared, just square root it, but then do second negative for a and s. So it'll put your answer right underneath. That way you don't have to round. This one's going to be, what, 26.72? Okay. Feeling all right with that? Let me know if your calculator is not functioning appropriately. Make sure you're in degree mode. Okay, now here is a very important public service announcement to all students. At this point, we might argue that we could potentially continue with the law of cosines, or we could switch to law of sines. Beware. Okay, here's my warning. If you switch to the law of sines right now, you run the risk of switching too soon, and potentially you would know that you would switch too soon at the end, because when you look at your triangle, like your longest side won't be opposite your largest angle, and your smallest side won't be opposite, or your shortest side won't be opposite your smallest angle. The only time when I would say, like, yes, go ahead, switch from law of cosines to law of sines, is if you are convinced that you have already found the largest angle. If you are convinced that you have the largest angle, then you can switch to law of sines and you will never run into this issue, or you should never run into this issue. But if you haven't found the largest angle yet, you want to be really careful, because remember that conversation we had yesterday about inverse sine? That it only answers on the right side, quadrants 1 and 4. Ours is not going to give us something in the negatives because we don't have negative sides. So we're always going to be getting acute answers. If there is an obtuse angle that exists in your triangle and you haven't found it yet and you switch over to law of sines, the law of sines will only answer acute. And it would be like, oh, that was the acute answer, but it was really the reference angle. It was supposed to be obtuse. That's really hard for you to tell, okay, until the very end when things don't match up. So is anybody convinced that we have the largest angle already?
Yes. Yeah.
Because?
Largest side.
It's opposite the largest side. When we found side B ended up being the largest side, so like 81 does have to be the largest angle. You could switch over to the law of sines. I am going to solve this in law of cosine since that's the one we're working with. So do you guys want to solve for A or B? A. And if you at your desk want to work on a law of sines, you should get the same answer that we get by law of sines. I'm going to do a cosine of A. Remember, if I'm solving for angle A, I'm going to be subtracting the A squared side in the numerator. So this is going to be minus a 22 squared. So I'll have like my 19 squared and my 26.72 squared added. Everybody, if you're doing a law of cosines, this is great practice for can you type it in correctly. See, I'm getting 0.5820 stuff. Okay, so let me know if you try typing in what I did and you don't get that. And then, of course, we want to solve for a, so we're going to inverse cosine this value. Again, here's another great opportunity to use like second cosine, second decimal, second answer. It'll do it for you. So I'm getting angle A to be 54.41. Anybody got any questions about that? Make sure you're typing it in, you're calculating, you're doing the work. We won't know that you can solve the triangle till you do it. If you switched over to the law of sines, you should have gotten the same answer. And now we can easily solve for what's our angle we need left is C. Because the three angles still have to add up to 180, so I could subtract the 81, subtract the 54.41, and that's going to be my angle C. Let me see, I have that one, 44.59, 44.6. Flag me down here in the next minute or so if you're like, I'm typing that in and I'm not getting the same number. Something is not right. Inverse cosine. Because the cosine of A is equal to that decimal. So I need to break into that using the inverse. Are you close?
Yeah, I was like,
Yeah. And if you switch over to the law of sines, there's still opportunity for you to be like slightly off just in terms of like the rounding thing. So that's why I would say like don't, try to like leave some numbers. When that's 26.72, I usually go to the hundredth, and if I use it again, my answers are more accurate. Anybody else got any questions there? How did I do something? Where'd something go? Okay, I'm not going to do this full next example, but I do at least want to show you a side, right? So here's an example. It looks like, hey, here's three sides of a triangle. So on this one, again, like how will you know when to use which formula? Well, I probably like law of sines. That's probably my favorite one. It's easy, it's fast. But if I can't find a matching angle and its opposite side, I'm going to have to use a law of cosines. So law of cosines is used for side. This is where I'm actually going to write it down. Always solve for the largest angle first. Now, if you're someone who, like, over the years, I'm just kind of, like, aware that this is an issue, that I could switch over to law of sines and I could get a potentially mismatching triangle. So, like, if I see a law of cosines problem, I just solve everything in law of cosines. Then I don't have to worry about it. Okay, I like that. But if you're someone who thinks that they might be switching out of law of cosines and into law of sines, this is a critical point for you, right? You have to make sure that you have the largest angle before you switch to law of law of sines. So that would mean we would solve for which angle first? B. Okay, so we'll just show the setup for B. And we'll put up what that answer is. And then I won't solve the whole thing because we have one area formula to do. I'm getting 0.125. And then inverse cosine. (82.82). Okay. And then, of course, you would like keep going. If you've made sure that you found the largest angle first, then you can switch over to the law of sines. But if you're comfortable with the law of cosines, you can keep solving for another angle with the law of cosines. So I actually prefer to just keep using the law of cosines so I never have to worry about this issue of mismatching sides. So you kind of decide what you want to do. Okay, solve for the other angles. All right, last thing that we want to go over is a new formula for area. So I have on the board over here this first triangle. If you knew like a side of your triangle and then you knew the altitude that came to that side, that would be like the height of your triangle. So we could use our very old base times height divided by 2, right? We like that one. We adjusted that one so that if we had side, angle, side, we kind of went in and we said, okay, here's the altitude. What would h actually be? Let me substitute that in. And we came up with a rule, something like this. 1/2 times the two sides times the sine of the included angle, right? It could be for any varying letters and angles. Okay, the new formula that I'm going to give you is, can you find the area of a triangle given all three sides? And it's not necessarily a right triangle, so you don't know what the altitude is. This gets a little bit messier, like actually finding the altitude using right triangle trig would be a little bit harder. The proof of this one is not nice. Watching the algebra for this is kind of like watching paint dry. So rather than give you a proof of it, I'm just going to provide you this one formula and say, like, believe me, this is a formula that works. Yeah, the S is important because S is in the other formula. So this is the area of a triangle. It's called Heron's formula. No. You'll have to know this. It's really not so bad. It does look bad at first. I totally agree. It's a little terrible, but it's really not so bad. It's this big square root. And under the square root, make sure you have 4 things. There's an S. And then there's S minus A, S minus B, S minus C. Which, I mean, once you kind of like figure that out, that doesn't require a ton of work. But this would be like if you knew 3 sides. So use for side, 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 and you would know then what A, B, and C are, because those are the sides, right? But then there's this question of what is S. So S is worked out over here. And what I want you to think about this S, we call it S because it's called the semi-perimeter. So how do you find a perimeter? Add up all the sides. So, of course, we know sides A, B, and C of our triangle. So we add up A, B, and C. That's the numerator. And semi means half. So it's just saying half of the perimeter. So first step is always find half of the perimeter and then use that S with your A, B, and C. So like the last example was a side, side, side. Example 2, I'm going to find the area of that triangle, okay, using Heron's formula. So find the area of the triangle from example 2. Here it is. I would start by doing S. 10 plus 12 plus 8, that's my perimeter. Divide it by 2. Get half of it. So this is 30 over 2 or 15. Excellent. Okay. If you're doing your practice on your homework, yes, you do have to know your formulas on quizzes and tests. So think about, okay, what can I know about this formula that will make it easier for me to do? Okay. I remember I always start with this S that I found, right? So I'm going to put 15 in there. And then the other three things are just your S minus the sides. Okay. So I'm going to show it out as 15 minus 10, 15 minus 12, and 15 minus 8. These numbers are easy enough that you could have said 5, 3, and 7, right? You could have actually done this subtraction. Okay. And probably the only other thing that I really want to say about this, because this is like, here's a formula, know how to use it, is beware with your square root on your calculator. A lot of us, our square root will bring up an open parenthesis to say like everything that goes behind this parenthesis is going to be in the square root. But you don't want to close it right after 15. You want to leave it open. You can, if you're not going to do the subtraction, you can enter more parentheses, but your final close should be at the very end. Okay, so if you want to practice this, I think it comes out to like 34 point.
39.69.
Really?
That's what I got.
Oh, okay, 39.69. Yeah, I did change it. You're right. Units squared. Okay, so if you want to double check and make sure that you can get that answer. Okay, so you have some problems tonight. Be thinking about, like, as we prepare for Thursday, how will you know when to use law of signs? How will you know when to use law of cosines? How will you tell yourself to check for ambiguous case? Okay, those are things that are going to make you an honors pre-calculus student.